If you zoom in far into a $1,000 GPU card, you'll realize that it is literally just a million of heavily engineered rock sand doing math. For most of our human history, sand was just another dirt. But inside this handful of crushed rocks is the foundation of the modern world, silicon. Every smartphone, every computer, the internet, artificial intelligence, and the device you are using to watch this video right now, they are all made of sand. We literally took rocks, trapped energy inside them, and tricked them into thinking. Over the next few videos, I'm going to show you exactly how we did that. Welcome to the magic of silicon. To understand why we build computers using sand, we first have to understand the core problem of computing, controlling electricity. In the physical world, most materials fall into one of two categories. First, we have conductors, metals like copper and gold. Their atomic structure is like a massive multi-lane highway. Electrons flow right through them, like in lightning speed. They are great for moving power, but terrible for controlling it. They are always on. And conduct. On the other side, we have insulators. Rubber, glass, wood. Their atomic structure is like a brick wall. They won't conduct at all. Electrons can't pass through. They are always off. If you want a machine to do math, you need to be able to switch between a 1 and a 0. You need a switch to count all numbers at least to the base of 2. But if conductors are always on and insulators are always off, how do we make a switch that doesn't have any moving mechanical parts? We need a material that can do both, a material that is semiconductive. Silicon, atomic number 14 on the periodic table. Now, you won't find pure silicon just laying around in nature, but you will find silicon dioxide, silicon bonded with oxygen. You know what we call silicon dioxide? Sand. It makes up over 27% of the Earth's crust. It is the second most abundant element on the planet, which is incredibly lucky for us because it has a superpower. Silicon has exactly 4 electrons in its outer shell. Atoms are happiest when they have 8. So to get happy, silicon atoms hold hands with 4 of their neighbors. They lock together into a perfect crystal lattice. It's exactly the same structure as a diamond. Because all those electrons are locked up tight, silicon acts exactly like an insulator. No electricity can flow through it. It's totally dead. But the bonds holding those electrons together aren't quite as strong as a diamond. If you apply just a little bit of heat or a very specific electrical pulse, the bonds break. The electrons start to move. Suddenly, our brick wall becomes a highway. The insulator becomes a conductor. That is the magic of a semiconductor. By changing the conditions, we can tell the rock when to let electricity flow and when to stop it. We can create a 1 and a 0. We have successfully created a switch. So we have our perfect material. It's abundant, it's cheap, and it can act as a switch. There's just one massive problem. This sand, it's full of impurities. Shells, dirt, iron, calcium, etc. If we want to build microscopic, perfectly precise cities out of this stuff, it needs to be pure. I don't mean 99% pure, I mean 99.999% pure. In our next video, we are going to melt this beach down, rip the oxygen away from the silicon, and grow the most perfect crystals in the universe. Thanks for watching. I'll see you in the furnace. Make sure to subscribe so you don't miss the next step of the journey.